This is the table that we use to estimate probabilities when our random variable follows normal distribution. We first transform it to z using the same formula that I have just discussed in the previous lecture recording. So for each corresponding value of z, we can find a probability. Let's take the z value of minus 2.4. So if we consider z minus 2.4, you can see we can follow this row, and let's suppose we have to identify the probability corresponding to minus 2.45. So we use row of minus 2.4 and we go to column of 0.05. This is how we get the location of the probability across z value of minus 2.45, and this is 0.0071 is the corresponding probability. Okay, so this is how we can get the z value and its associated probability located from this z table. It has two pages. The first page gives us the royal values of probability corresponding to the negative values of z. The other one gives us the probabilities across the positive values of z. And how can we classify or divide the table into two components, that is left or right, or negative or positive. So over here we can see if we take the value of x exactly equals to mu, so we take this difference to be 0 for x equals 0. We take this z value 0 divided by sigma, and that gives us 0. So if we move across this horizontal axis, this is the point where we observe value of x equals to mu exactly. So we can say that the central value of z is equal to 0 once x is transformed to z. If central value across mean value of the random variable is 0, therefore this entire axis across the left hand side of the z value is negative, and this will become positive. So negative z values we locate over here, and all positive z values we locate above the 0 region under the curve. Now let's take an example so we can solve some questions related to z distribution. So I'm taking this example. Let's suppose that the mean height of all the students is equal to 80 and the standard deviation is 10. So we can now state this description if we assume that the height follows normal distribution, or if we are given this assumption right there in the question that random variable x that represents the height of individuals or students follows normal distribution with mean mu and variance sigma square. So we can restate it in in terms of the values that we are given in the data. So this is how we can do it. Now let's suppose we are asked to determine some probabilities, and we start with, let's suppose we are given the case that we select a student at random from the class. Then what is the probability that that randomly selected student has a height below 70? Now what we do, using this formula, x take away mu divided by sigma, we transform it to z. So we get z below 70 minus 80 divided by 10. This is one way of expressing your conversion. Another easier alternative is you do this entire conversion separately and just substitute the answer with inequality sign over here as probability of z below -1. So below -1 is in fact -1.00. Now what we do, we go to the table, we find out the row of -1, that's over here. So -1.0, and the very first column has a header 0.00. So when we want to get the z value located, which is -1.00, then the probability across that z value is 0.1587. This is you can see. Now the answer is 0.1587, or if we would like to express it in percentage terms, it is 15.87% chance. How do we interpret this answer? We have selected a student at random and we were asked to determine or identify the probability that it has the height, or that person has a height less than 70. So we can interpret this as there is a 15.87% chance that the randomly selected student has a height below 70. Now similarly, if you are given another question, and first before moving to that question, better if we like to show this working under the curve. Now see, as per the information given in the question, this mean value is 80. When we talk about 70, we can get 70 located somewhere over here. And this is the area that we can shade. This is what we were asked for, and how we have determined this. You know this very well, and this answer is 0.1587. So 0.1587 probability must be located below this borderline. So what do we understand regarding the use of z distribution after applying this or determining this answer is z table gives us the area below a particularly selected borderline. So if we have got the borderline of 70, when we have transformed this 70, we got -1.00, and minus across -1.00 or below -1.00, we can find out the probability of 0.1587. So this is the entire area below this borderline. What we understand, the z value or z table gives us the area below a borderline always. Now when we are asked to determine the area above a borderline, let's take this example. X greater than 80. Let's take it as 90, not 80. X greater than 80. So what we do, we again get it transformed. This time I would prefer to get it transformed separately. So 90 minus 80 divided by 10 gives us 10 divided by 10 equals 1. So probability of z greater than 1 this time we are interested in. So if we draw the curve, then 70 lies here, 80 lies here, which is a mean value. Then 90 would be located above 80. And we are asked this time the area above this borderline. But as we have determined already, is understood this concept that z table, whenever we refer for any value, it gives us the area below a particular borderline. So this time the borderline is 1. So when we check z table for the value of 1, it would give us this entire area, what I am indicating with dots. Area below it would give us entire area below 1. Now if we check the probability corresponding to z value of 1 from the table, this is 0.8413. So this area which is below z value equals -1 under this curve is 0.8413. How do we determine the area above? Because we are asked for this in this question. So the total area under the curve is 100% or the probability is 1. So from 1, when we take away this probability 8413, we get the answer 0.8517. Over here, coincidentally, the answers of the two parts are coming same because symmetry is involved in z curve. -1 from the central value of 0 is located at the distance same as +1. Now, coming to part C, if we are asked for determining the probability that a randomly selected subject has a height lies between 60 and, let's suppose, 80, 60 and 100. So if we transform these two values one by one to z, 60 take away 80 divided by 10 would give us minus 20, minus 2, sorry, minus 20, and then divided by 10 will give us minus 2 exactly. And then 70 and then 100 minus 80 divided by 10 equals to 20 divided by 10, which would give us 2. So over here we will be getting minus 2 and plus 2 as the lower and upper bounds for the converted values of z. Now if we refer the z table for z value of -2 and +2, this is how we can address this problem, or we can determine the answer in this way. This is z x equals mu, whereas z equals 0 over here. When we indicate +2 borderline, should be located here. -2 borderline should be located here. So when we refer the z table for +2, it would give you the entire area from the left extreme to this borderline. And when we refer the same z table for the probability across -2, it would give us the probability or the area up to -2 under the curve from the left extreme. So when we subtract from this larger area, this smaller area, this is how we get the area between these two borderlines. And this is how we do it. So this is how we can write down the probability below z equals minus z equals 2 minus probability z across -2. So if we refer the table again, we can locate the value of z across 2 as 2.0.9772 is the value. So the value across this value of z is 0.9772. and the value across minus 2.0228. Okay, so this is how we can do it, and the answer is no point 9544. So this is how we can answer and determine the area between two border lines with the help of z table.